Myself, I am Bhanu Prasad, working as assistant professor in MBR Engineering College and Technology. Today we will discuss about DNC control systems and adaptive control systems. So see here DNC, direct numerical controllable. So direct numerical control is a manufacturing system in which number of machines are controlled by a computer through a direct connecting in a real life is known as the direct numerical control. Direct numerical control is one of the manufacturing systems in which number of machines are controlled by a computer through the direct. So number of machines are controlled by a computer through the direct connection one and a real time is known as the direct numerical control. So one computer can be used to control 100 separate machines, and it is designed to provide the instructions to each mission tool on a demand one. So this one we can call as the direct numerical control. So in previous lecture we will discuss about NC missions, CNC missions, but in this today lecture we will discuss about DNC, direct numerical control one. So in direct numerical control one, it is one of the numerical control one. So in this numerical control one, the computer can control the total number of machineries through the direct connection in a real time is known as the direct numerical control one. So one computer used to control 100 separate machines, and it is designed to provide instruction to the machine tools on a demand is known as direct numerical control. So see here, so it is the basic structure of the DNC one. So it is a computer. So direct connection onwards, we can control the number of machineries. So these are the number of machineries. So one single computer directly we are connecting to the number of machines one. So can do the operations on number of machineries one. So this one we can call as the direct numerical control one. One computer can control number of machineries. So that's why we can call as it is one of the DC, direct numerical control on a real time one. It is real time one. It is controlling number of machineries. So that's why we can call as it is one of the DC systems. So you see here general configuration of direct numerical control. So see here general configuration of a direct numerical control system. See here it is a central computer one. It is a bulk memory NC programs one. So see here a computer one. So it is a computer. This computer connection is given to the telecommunications lines. So see here each and every connection is sent to the program is sent to the MCU one. The MCU directly sent to the machine tools one. So just a second machinery. So based on the computer, we are arranging four types of machineries here. Directly, the input program is sent to the MCU. MCU is sent to the MCU is can convert to into the program instruction to the mechanical motion one. So that's why it is these mechanical motion is sent to the late machine NC machines one. So this one also the program is sent to the MC one, after then sent to the late machine one. So these one telecommunications lines, these are the these input is given to the MC. MC then convert to the mechanical motion and to the late one. So this is a connection one. This is general configuration of a direct numerical control system. So now it is the bulk memory for NC program one. So this more central computer one, it is bulk memory. So through the computer onwards, we are giving to the four machineries connection one. So directly it is controlling and doing the operation on these four machineries one. So this type of process, this type of layouts we can call as the direct numerical control systems. So connection to the MCU is behind the tape reader. So BTR. So see here connection to the MCU one. So behind the tape reader, it is a tape reader BTR. So in distributed NC, entire program are downloaded to each MCU. So in distributed NC entire program. So the distributed NC program are downloaded to each MCU one. So each MCU onwards, the program will be downloaded here. So which is CNC rather than conventional NC one? Which is CNC rather than conventional NC missions is called as the general configuration of direct numerical control system one. So see here, and what is the advantages and disadvantages of direct numerical control? So it is one of the what are the advantages, what are the disadvantages? See here advantages, greater computer and flexibility. So here we have the greater computation and flexibility we can see. So in advantages one, second one is eliminates use of punches tapes. So eliminate the use of punches tape one. So converting storage of NC path programming in computer files one. So direct conversion of data from CAT to NC program one. So increasing productivity, save time. So these are the advantages of the direct numerical control. So DNC systems one. So see here, first one is greater computational flexibility we have in this DNC machineries. Second one is eliminates use of punched states. That is the second advantages. It is eliminates the punched states one. Third one is conventional storage of NC path programming in computer file. Conventional storage. Storage in NC path programming in computer file only. The storage total program is in computer file only. So direct conventional of data from CAT to NC program, direct converting data from CAT to NC, direct, there is no medium one. So directly the program CAT to it is directly converted into the NC machines one. So next one is increasing productivity. So it is automatically day to day for hour to hour, it increasing the productive one. It is save the time one. So it is saving the time. So by using the direct numerical control, it is saving the time. Why? Because so one computer based on we are running these so many machineries, so that's why we can call as it is a direct numerical control one. So comes to here one, these are the disadvantages here. So the only disadvantage of DNC is the computer breaks down, but the computer is so reliable, so that this is unlikely to occur. So some example one, suddenly the computer will be break down, what happened, the total production will be stopped suddenly one. So that is one of the drawback or disadvantage for the direct numerical control one. So some type likely terminal based DNC systems and network based DNC systems are expensive ones. So some types some of the DNC machineries thermal based on DNC systems and network based on DNC systems are expensive ones. So these are, we can use it some systems terminal based network based on what, so DNC DND systems are very expensive ones. So that is one of the disadvantages for the direct numerical control. So these are the advantages. These are the disadvantages of the direct numerical control. So next one we can see adaptive control. Adaptive control. So first topic is DNC, direct numerical control one. Based on the computer, we can control the number of operations, number of machineries one. It control the number of machineries, number of operations. It will be controlling. So that's why we can call as DNC, direct numerical control one. But comes to here ACS, adaptive control systems. So it is a logical extension of the NC and DNC one. So it is a one of the logical extension of the NC and CNC one. So in previous lecture we will discuss about NC and CNC. It is a logical NC and CNC logical extension is nothing but adaptive control systems. So it is an improvement of the cutting process. So it is the why, because they are using these ACS means why they are extended these ACS systems means in NC and CNC machines. So it is improving the cutting process one. So improvement cutting purpose, they introduce the AC systems. So by automatic online determination of the feed and cutting speed one. So it is the improvement of the cutting process by automatic online determination of the feed and cutting speed is known as the adaptive control systems one. So next one is basically feedback system in which the cutting speed and feed automatically adapt themselves to the actual condition of the process one. So it is one of the benefit for the adaptive control systems one. Basically feedback systems in which the cutting speed and feed automatically adapt themselves to the actual conditions of the process one. So this one we can call as adaptive control systems. It adapted themselves to the actual conditions of the process one automatically. So that's why we can call as it is adaptive control systems one. See here, cutting speed and feed have to be varied in such a way as to improve the performance levels one. So the cutting speed and feed have to be varied in such a way. Why? Because they are improve the performance level one. So the speed and feed will be added. Why? Because to implement the performance level one. So that is one of the major advantages for the adaptive control systems one. So it is the basic introduction about the adaptive control systems. This adaptive control system is nothing. It is the logical extension of the NC and CNC missions. So NC missions we have, CNC missions have. But based on these two ones, they are extend the adaptive control systems. So why? Because improvement of the cutting process by the automatic online determination of the feed and cutting speed one. So this purpose they introduce they extend the adaptive control systems one. So basically the feedback system in which cutting speed and feed automatically adapt themselves to the actual condition of the process one. So that's why is one of the major uses one. Automatically it adapted themselves to the actual condition of the process one. So next one is cutting speed and feed have to varied. Speed and feed are varied such a way. Why? Because it improve the performance level now. So that's why this type of points onwards we can call as it is one of the very important adaptive control system one. So see here basic structure of ACC adaptive control systems onwards. So see here requirement force one. This is a so in this adaptive control system once it is spindle speed, it is a few times feed limits. So this field limits it is a speed spindle speed one. So it is a required force one. So adapt to control routine here. So next one is we send to the adaptive control and so we send to the feed rate routine. So in this one we have the clock timing also. So after then we send to the logical direction control loop one. So it is a longitudinal z direction and we have the x direction also. After then we send to the lathe one. After then in lathe one we have the two connections one positive velocity sensors. Again it's sent to the direction one. So next one we have the force sensor. Force sensor we send to the amplifiers. See here again this force sensor then sent to the amplifiers, the ADC. Next one is sent to the adaptive control routine one. So this is the basic structure of ACC among the program starts from like this onwards. Required force onwards, it is sent to the adaptive control routine one. After then it is sent to the feed rate routine one. After then it is sent to the axis control loop one, x axis, z axis one. Again we send to the lathe one. In lathe one the operation will be done here. But in lathe one we have the two connections. The first one is positive velocity sensor one, positive and velocity sensor. It is a force sensor. So two sensors in here. The positive velocity sensor again we give to the longitudinal x direction control loop one. So this longitudinal x direction control loop control the sensors one. So comes to the force sensor we give to the directly to the adaptive controls routine one. So why we see here again the force sensors we give to the here. Why? Because it is a required force required one. So that's why this force sensor is connection to the this adaptive control routine one. So that's why IMP, the ADC, again we send to the adaptive control routine one. So it is a computer. So it is the basic structure of the ACC, adaptive control systems ACS. So next one is benefits of AC adaptive control system. So what is the benefits of the adaptive control systems means see here increase the production rates. So it increase the production rates one. So it increase the tool life one. So greater product part production one, less operation intervention one. So these are one of the basic benefits and basic advantages of the AC one adaptive control. First one is increased production rates. So automatically when we can use an adaptive control system one. So what is the major benefits means we can observe the increase in the production rates one. So second one is increase in the tool life one. So automatically it increase the tool life one. So next one is greater part production we have in this especially for automatic control adaptive control system onwards. So next one is less operations intervention one. So these are the one of the benefits for the AC one adaptive control systems one. So these are the overall thought in it, overall thought in it. So these are overall thought in it. You learn these are the topics one. So comes to thought in it is path programming for NC missions. In path programming for NC missions, first one is basic introduction about the NC one. So in the NC missions basics that is the first topic one. Next one is principal operation of NC one. Next one is we can see NC modes one. So next one generally we have the four types of modes one. So that one. So next one is modes onwards we can start for features of NC missions. So that is our NC missions topic. So next one is we can see for so CNC one introduction about the CNC. So next one is the CNC modes one and the features of CNC one. So in CNC one we have the so based on the tools one we have the features, based on the missionaries we have the features one. So that is the advantages and applications of the CNC one. So that is the CNC topic one. Next one is today topic is DC one. So DC and AC one. AC is control systems one. DAC means direct control systems one. AC means adaptive control systems one. So these are the overall thought in it. Comes to our topic. These are thought in it one. So that our total thought in it is completed one. So next one we can start for fourth in it. So start for fourth in it. Group technology. So group technology, why we start this unit means I previously I told you. సో సెకండ్ యూనిట్ మనకు వచ్చేసమ్మ టోటల్లీ అది ల్యాబ్ రిలేటెడ్గా ఉంటుంది. సెకండ్ యూనిట్ మొత్తం కూడా ఎందుకంటే ల్యాబ్ రిలేటెడ్ ల్యాబ్ మీకు అర్థమవుతానే ఆ యూనిట్ కూడా చెప్పిన అర్థమవుతుంది. ఎందుకంటే మన టోటల్లీ డిపెండింగ్ ఆన్ 2D 3 డైమెన్షనల్ ఆబ్జెక్ట్స్ కూడా ఉంటాయి మొత్తం దాంట్లో సెకండ్ యూనిట్లో. సో ఇట్ ఈస్ వన్ ఆఫ్ ది డిజైన్ అండ్ మోడలింగ్ వన్, modeling and drafting process that is completely related to the lab one. So that's why when the lab will be started, when that purpose we can start the second unit కూడా. ఎప్పుడైతే మనకి ల్యాబ్ స్టార్ట్ అవుద్దో ఆటోమేటిక్గా మన సెకండ్ యూనిట్ కూడా స్టార్ట్ చేస్తాం. ఎందుకంటే ఇప్పుడు ఈ ఆన్లైన్ టైంలో నేను సెకండ్ యూనిట్ మీకు స్టార్ట్ చేసి సో మిమ్మల్ని కన్ఫ్యూజ్ చేయడం నాకు ఇష్టం లేదు. ఎందుకంటే రిమైనింగ్ యూనిట్స్ చాలా మీకు ఈజీగా అర్థం అవుతుంది. నేను అవైలబిలిటీగా ఉన్నా లేకపోయినా easy to understand this type of topics one, but second unit is not, you can understand why, because it is a lab related unit one. So that's why I will start today. I will start for fourth unit, but it is actually syllabus one, it is a fourth unit, but our comes to our topic one, it is a third unit one. సో సెకండ్ యూనిట్లో కూడా మాక్సిమం మిడ్ లోపల ఏదో 2 టాపిక్స్ అని మీకు కంప్లీట్ చేసేసి మిడ్కి ఇచ్చేస్తానమ్మా. నో డోంట్ వరీ. సో ఎందుకు మీకు ఇవ్వట్లేదంటే మేజర్ రీజన్ ఇదేనమ్మా, ల్యాబ్ రిలేటెడ్ ఈ టాపిక్స్ అవి మీకు ఇప్పుడు స్టార్ట్ చేస్తే మీకేం అర్థం అవుతుంది. 2D 3D సో అరైజింగ్ డ్రాఫ్టింగ్ ఇవన్నీ మీకు కూడా క్లియర్గా నేను ల్యాప్టాప్లో నేను ఎక్స్ప్లెయిన్ చేయలేదు. అదే ల్యాబ్లో ఉంటే ల్యాబ్ మీరు చేస్తూ ఉంటే ఒక్కొక్క పాయింట్ నేను ఎక్స్ప్లెయిన్ చేయడానికి పాసిబిలిటీస్ ఉంటాయి. మీకు ఈజీగా క్యాచీగా అర్థం అవుతూ ఉంటుంది. సో ఈ టైంలో నేను ల్యాబ్ లేకుండా మీకు ఎక్స్ప్లెయిన్ చేస్తే ఏమవుతుందంటే కొంచెం డిఫికల్టీగా ఉంటుంది. అంటే మీకు నేను ఎంత 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 నేను ట్రై చేసి మీకు ఇంకా క్లియర్గా ఇంకా ఈజీగా ఎక్స్ప్లెయిన్ చేద్దాం ఉన్నా కూడా యూ కెనాట్ అండర్స్టాండ్. సో దట్స్ వై టుడే ఐ విల్ స్టార్ట్ ఫర్ fourth unit. In syllabus one, it is a fourth unit, but comes to our topics, it is a third unit one, group technology. So see here, group technology, GT. So the GT is a manufacturing philosophy. So GT is one of the manufacturing philosophy in which similar parts are identified and grouped together to make advantage of their similarities in design and production one. So this one we can call as the production group technology one. So group technology is one of the manufacturing philosophy in which similar parts are identified. So in this group technology, similar parts are there identified. Similar means common. So based on the size, based on the same one, similar parts are there identified one and grouped together. So in this group technology, what the major role of this group technology means, similar parts are it will be identified and grouped together to make the advantage of their similarities in design and production one. So this one we can call as the group technology. సో గ్రూప్ టెక్నాలజీ అంటే ఏంటంటేమో సిమిలర్ పార్ట్స్ ని ఏం చేస్తుందంటే సిమిలర్ పార్ట్స్ అండ్ హౌ కెన్ వీ నో అంటే బేస్డ్ ఆన్ ది సైజ్, బేస్డ్ ఆన్ ది స్ట్రక్చర్ అండ్ బేస్డ్ ఆన్ ది డైమెన్షన్స్. మనం స్ట్రక్చర్ బేస్ చేసుకుని అంటే ఒకే స్ట్రక్చర్ లో ఉన్నాయి అన్నిటిని కూడా గ్రూప్ టెక్నాలజీ ఏం చేస్తుంది అంటే ఐడెంటిఫై చేస్తుంది. ఐడెంటిఫై చేసిన తర్వాత ఏం చేస్తుంది అంటే గ్రూప్ గా ఫామ్ చేస్తూ ఉంటుంది. సో టు మేక్ ది అడ్వాంటేజ్ ఆఫ్ దీస్ సిమిలారిటీస్ ఇన్ డిజైన్ అండ్ ప్రొడక్షన్ వన్. సో ఇట్ ఈస్ ద అడ్వాంటేజెస్ దేంట్లో అంటే డిజైన్ లో కానీ ప్రొడక్షన్ లో కానీ. సో దిస్ టైప్ ఆఫ్ టెక్నాలజీ ఈస్ వెరీ యూస్ఫుల్ వన్. సో వీళ్ళు ఏం చేస్తారంటే సిమిలారిటీస్ ఉన్న పార్ట్స్ ని ఏం చేస్తారంటే ఐడెంటిఫై చేసి గ్రూప్ చేస్తారు. సో దట్స్ వై ఇట్ ఈస్ కాల్డ్ అయితే గ్రూప్ టెక్నాలజీ. సో similar parts they are arranged into the part families. So similar parts are it is arranged into one of the part families. So we where each part family possesses similar design and or manufacturing characteristics. Each part family can possess a similar design. So based on the structure, so that is nothing but design one or manufacturing characteristics. So this purpose they are arranged into the group one. The group is nothing but one of the part family. So grouping the production one, grouping the production equipments into the machine cells. Grouping the production equipments into the machine cells. So the equipments is arranged into the machine cells one. So which where each cells specialized in the production of the fat families. So each cell specializes into the production of the fat family. So that's why we can call as one of the cellular manufacturing. So this type of process we can call as one of the cellular manufacturing one. Why? Because so the total production equipments we are arranging into the one machine cells. So the total production equipments we have so many equipments. So the total equipments is nothing but raw materials we have. So cutting one, so extra uses materials also we have. So the total equipments they are arranged into the one machine cells one. So each and every cell they are specialized in the production of the fast family one. So that's why we can call it is one of the cellular manufacturing one. So next one you see here, it is the basic introduction about the group technology. So see here benefits of the group technology. So it affects all areas of the company including one. So the group technology, these are the applications where we can use it for group technology. Means first one is engineering one. Engineering field we can use it. Equipment specifications we can use it group technology. Next one is facilities planning purpose we can use it for group technology. Process planning purpose we can use it group technology. Production control purpose we can use it for group technology. Quality control purpose we can use the group technology. Tool design purpose we can use the group technology. Purchasing purpose we can use the group technology. Next one is service purpose we can use the group technology. So these are the benefits of the group technology or applications of the group technology. These types of fields they are used for group technology. First one is engineering one, equipment specifications one, facilities planning one, process planning one, production control one, quality control one, tool design, purchasing, services. So these purpose we can use it for group technology. These are the benefits and advantages of the group technology. So next one is comes to here path family. So the first one is number of parts are grouped for path family. So what is the path family? Path family is a collection of similar parts which are grouped according to their geometric shape and size. So see here, path family. What is the meaning of path family? Means it is collecting the similar parts which are grouped. So the similar parts are they are collecting and gathering into the group one according to their geometric shape and size. Based on geometric shape and size onwards, they are collecting this type of parts one and they are gathering into the group one. So this one we can call as path families. So sometimes the paths within a family are different, but deserve their identification as member of the path families. Their similarities are close enough one. So sometimes the parts within a family are different one, but two but different. See here, but it is sometimes it will be different parts are, but so desire their identification as member of the families. Their similarities are close enough one. Their similarities are close enough. So they are grouped together one. So that one we can call as a path family. So these are the examples amma. So see here similar ga unnayi kabatti so same ga unna similar parts similar shape and size ఉన్నా కూడా గ్రూప్ ఫామ్ చేస్తారు లేదా సో ఇట్ ఈస్ క్లోజ్డ్ ఎనఫ్ ఉన్నా కూడా we are grouped together one. So this one we can call as a path family one. So it is the introduction about the path family. So methods for path family. So we are grouping the are collecting the number of parts here. So that's why we have some methods in path families. We have some methods. One there are three general methods for solving the path families grouping. All are three are time consuming and involving the analysis of much of data by properly trained personals. There are three methods one. So see here generally we have the three types of methods. So for solving the path families grouping, for solving the path families grouping one. So we have the one problem one. So in total industries one, so number of parts we have. So in number of parts collecting purpose, we can choose for path family. In path family we have that three types of methods one. So these type of methods they are solving the path families grouping one. So these three methods they are solving the path families grouping one. So that is the point here. All the three are time consuming and involving the it is a time consuming one. So involving the analysis of much of data by properly trained personals. So it is one of the time consuming one and involving the analysis of much data by properly trained personal one. The three methods are first one is visual inspection one, second one is path classifications one and coding one, third one is production flow analysis one. The first one is visual inspection one. So the first method for path families is visual inspection one. The second one is path classifications and coding one. The third one is production flow analysis one. So these are the methods for path family. So these are the methods for path family. Amma. Thank you, Amma. It is our today class one. So once again, I am repeating the today class. First one is today our topic. First one is DC missions, direct numerical control systems one. So basics and introduction of the DC one. So and basic principal operations of DC one. So general configuration of DC one and benefits of DC one. So that is the DC total, direct control system topics. One next one is next one we can start for adaptive control system. Adaptive control system is nothing but, so it is the total extension of the CNC and the NC machines. Why? Because we can get the more accuracy and more speed, more production dates for the cutting speed one. So cutting speed and field purpose, they introduce the adaptive control systems one. So that is the introduction and the basic configurations and the advantages of the adaptive control systems one. And next one is we can start for 15 in one. So in 15 it is group technology. Group technology is nothing but it is one of the passive one in which similar parts are identified and grouped together one to make some advantage of the similar design and production one. So this is the introduction about the group technology one. In group technology we have the one path family. So benefits of the group technology is one. Next one is we can see the path family. Farm family is nothing but collection of the similar parts in which group would according to their the geometric size and shape ones. Geometric size and shape onwards they are grouped together in path families one. So this one we can call as path family. So in this path family they are collecting the similar parts. So we have the three methods one in collecting the similar parts one. So we have the three methods. Why they introduced this type of methods means, so industrials we have the number of parts, spare parts we have. The spare parts identify the spare parts based on the size and shape one. So grouping purpose they introduced this path families one. So the identification purpose we have the three methods in path families. The first one is visual inspection one. Second one is path classifications and coding one. Third one is production flow analysis one. So thank you, Amma. This is our today class one. So tomorrow class we will discuss about methods of path families. First one is visual inspection one, path classifications and coding one, production flow analysis one. So these three topics for the next class one. Thank you, Amma.